Hi everyone, my name is Zhamak. I work for ThoughtWorks, and I like to be able to introduce myself like James, a colleague before me who gave a talk, as a coding architect, only if you count whiteboards and PowerPoints as valid programming stacks. Excuse me. The last 3 years I've been helping our large clients in Australia and United States to implement microservices and migrate their architectures. So I'm here to talk about that experience with you. It really feels like it was yesterday. Can you believe that it's been already 4 years that we've been talking about microservices? Microservices is an architecture that promised us the ability to be able to compose really flexible systems by putting small and single-purpose services together. Single-purpose services that each are built around a domain or business capability. With their interconnected network of resilient services, beautifully choreographed, we give our users an uninterrupted experience. We have really felt as a developer community, passionate about this grassroots movement. Microservices has been a grassroots architecture movement that came from developer community with the promise that each development team can own the destiny of their services from idea to production. We have embraced the complexity of building distributed systems. We have invested a huge amount of effort and energy into building automated delivery pipelines that they can be federated to build and deploy services automatically and smoothly. And it's probably for the first time that we can claim we can truly release capabilities to production independently. It does sound very utopian, doesn't it? And from the crowd, I can say that a few of us are heading towards that utopian target or destination. And yeah, the reality is that the road to this utopia is not that straightforward. And what I'm trying to share with you today is some of those obstacles that you come across building microservices, especially in large organizations, where you don't start from greenfield. You've got large monoliths and a lot of organizational obstacles along the way. And the good news is that I'm going to share some of the tactics you can move to maneuver around these obstacles. And when I was putting these slides together, I realized that how common the patterns are across different industries. So I've seen them in telecommunications, in commercial insurance, in banking, retail, and recently supply chain. And the very first one is an organizational problem, how the teams are formed, how the money flows within the organization. The second one is the old battle of monolith. How are we going to move our architecture from large legacy systems to microservices? And once we get over those obstacles, how to curb the enthusiasm of service modelers to not go too micro too quickly and not jump into microservices architecture without the operational and organizational readiness. So if you think that the biggest challenge you have building microservices architecture is your technical capability, your DevOps practices, and you have a technical challenge on your hand, think again. One of the biggest problems that you find is an organizational problem. And by that, I mean two specific problems. The very first one is this thing called portfolio planning or annual budget planning. Some companies, it happens more than once a year, where teams come together and propose projects that they want to get budget for to carry out over the course of the year. And that process in itself is very hard, and with that process, it's very difficult for us to be able to sell re-architecture and be able to get money to do microservices, goodness. And the second problem is the idea of ephemeral project teams. James talked about that. Half of his talk was about that one. So I'm not going to go through a lot of details, but it's the idea that we don't have long-term teams that they can own the destiny and have the responsibility of the services they build. So let's jump into the first one, portfolio budgeting. The story goes like this, and I've seen it in many organizations. Around this time of year, depending on when your financial year starts. If it's February, January, it's around this time of year, different teams or different functions within the organizations come together with a wish list for the projects they want to carry out next year. So product people, business people, they come with a business set of projects, trying to get funding. Tech come with their tech initiatives, trying to get funding. And what happens next is a messy sword fight. So basically, people are fighting over the same bucket of money. They need to justify the value of their projects. And often, they've gone through some lengthy and artificial process of justifying the value. And poor tech guys, they have a hard time. We have a hard time to sell the value of your architecture. We want to spend money to go from the monolith to the microservices. So there are a few things we can do to address that. The very first thing is that as techies, we need to become better salesmen. We need to think about why we need to build microservices architecture and be able to really clearly and clearly articulate the business incentive behind that architecture. So the organization I'm working with right now, they want twice the speed of delivery. They want to go twice as fast, and they want to do that with microservices architecture. If you're Netflix or someone like Netflix, maybe the scale of operation is your business incentive. Overnight, you went from selling DVDs to streaming, online videos to millions of users. So expanding that to that scale might be your business incentive. Or if you're like a commercial insurance company I worked with last year, you want to have a business that can pivot. A business can package different offerings and compose, kind of different solutions to your users. So in a commercial insurance, you sell car insurance, housing, buildings, employment, and so on. And you want to be able to compose these different packages and sell them online through brokers, call center, and so on. So that composability, it might be your business incentive. But the most important thing is that you need to be able to sell that idea and be able to articulate it. The second problem is with this annual budget planning is that the list of projects are quite disconnected. Business has a list of projects that's completely disconnected from the tech instead of each of them supporting each other. So with my client right now, we're trying to go from a really large e-commerce legacy system to microservices. And what we decided to do was, for the first time, get business and tech into the room, put them together for a few weeks, run these really collaborative workshops so they can align architecture with business needs and consumer needs. We started this process of top-down, okay, what are the consumer needs we try to address? What are the business capabilities we're trying to build? And map that to the domains and different services that the microservices architecture can build. Really be able to join those two different disjointed processes together and align tech and business. And once you do that, getting budget for architecture is much easier because you either tax the business projects that are running, or business projects becomes a delivery vehicle for your tech change, or tech becomes an enabler for your business. So it's a good kind of feedback between the two. And this is a transformation. This is not a change that can happen overnight. You have to be able to bring people along the journey and really plant the seeds of platform thinking and system thinking rather than this disjointed feature thinking. So at the end of the workshop that we ran, multi-week workshop, I asked the leaders of each different functions, the business and the tech, to go back, face their corresponding team members and tell them why this architecture matters to them, what's in it for them, and also be able to tell them how they need to change their behavior. And I was really surprised and kind of excited and happy at the end when I heard the head of product management kind of turn to his team and said, you need to stop thinking about features and independent features. You need to start thinking about services and APIs. So it's you start thinking about how you solution and how you build your business differently. The second problem in an organization is the team structure. The problem is that we do not have a team that supports a service. As James mentioned before, we have these project teams. You get the budget for re-architecture or building microservices. The first thing happens, the organization goes, oh, we need a project team. We need to scramble a project team together. And what that means is they deliver some functionality and they dissipate. Nobody stays around to own what they've built. There's no incentive of reducing tech debt. There's no incentive of, building and running services smoothly, because you're not the one getting the call when the service goes down. So the idea of having long-running product or service teams is, again, another organizational shift that we need to make happen. But what is the path to making organizational transformation, without a big revolution in our organization? It's an evolutionary path. The process that we're trying to apply is very much like the lean practices. And at first it was quite daunting for me. If you had a hypothesis that, using microservices will make your business go faster, or compose solutions, with more agility, you need to start evaluating that hypothesis and prove it. So you need to come up with the first slice, a proof of concept that you can build to validate that microservices is actually moving you towards that direction. This really challenged me when I started doing this work, because in my head, whenever we said re-platform, re-architecture, it meant an upfront, investment of building foundations. But the beauty of microservices is that you can start small, you can start faster. As we heard earlier from Fred, that there are lots of open source platforms and community work that we can use to start building our first slice and prove that we can achieve the business objective with this. We build a small skilled team together, and once that proof of concept is validated, we can start expanding and evolving that to the rest of the organization, and follow this kind of evolutionary path. The second problem, or the challenge with microservices in large organizations, is the construction of the monolith. And really, the problem is not how I'm going to theoretically decompose this giant piece of code that I've built over tens of years into smaller services. The problem is how I'm going to do this in a financially viable way. So to give you an example, we often really underestimate how much it costs to detangle a piece of code that's been in a monolith out into a microservice and redirect the rest of the applications to use that. And because of that cost, we have to continuously do this trade-off of, shall I reuse the code that I have and extract it and clean up what's left behind? Or shall I rewrite a piece of code to implement an existing capability? Or shall I buy or get off the shelf, open source, and retire and make redundant and inaccessible the code that I've got in the monolith? And it's a continuous cost and benefit analysis. The example I wanted to give you about the cost was a client I worked with. They had 2.5 million lines of code building a big commerce platform. To give you a perspective, yesterday from Anita, we heard that Mars rover has 500,000 lines of code to land on Mars. So 2.5 is quite a large number, and it sits kind of between Hubble Space Telescope, answering the universe mysteries with 2 million lines of code, and Large Hadron Collider in CERN. The root software for that is 3 million lines of code. So we talk about a large amount of complexity. One might argue that neither of those take a credit card payment like an e-commerce system. But how can we handle this complexity? So there are a few steps we can take to help us along the way. The first one is finding the seams. By the way, none of my videos work. The first slide was a video of this utopian, moving stars, and this one is a video of this elastic star, but it doesn't work. You can visualize it, that these are kind of moving. What this was a visualization of a large .NET study application, and it was a big ball of mud. And what we were trying to do was run static code analysis to find the package dependencies and really find the boundaries of where these lines of code where we could separate exist. Unfortunately, in this case, there weren't very clear lines. So the cost of getting a package that is nicely built around the business context, like students or course material or whatever concept they had, was going to be very costly. So perhaps rewrite or copying code would have been a more appropriate approach in this particular case. Again, to help evaluate the, the cost and benefit of the reuse, we need to pay attention to the code toxicity. So this was, again, another analysis we did on a code base, which was supposed to show us the healthy part of the code that is lively, as in being changed regularly, versus a toxic part of the code that's hopefully dormant, nobody's touching it. So we were hoping to see large, kind of light blue circles. What we saw was lots of dark circles, large circles, which meant basically toxic code that is constantly under change. Again, if you want to pull out toxic code, you might want to think twice about the cost of doing that. And sometimes we write those codes, and over time, they become quite toxic. So it's hard to let go, hard to justify that. Let's just move on and start from scratch. Right. The third one is theory of constraints. That is one of my favorites. So with theory of constraints, you try to find a bottleneck in your system that is stopping you to achieve the objective of your microservices architecture. So if you wanted to decompose your system to move faster, you will find out what in your system is stopping you from unlocking that decomposition. This was a migration strategy for a monolith that we were working on decomposition. Unfortunately, I couldn't name the real services and the real apps that they were sitting in the monolith. It's a client's application, but they kind of have everything as services front end. Everything's kind of sitting in this monolith, and it was a web application. And I can assure you, if you're have built a web application, that's evolved over the last 10 years or so, probably one of the hotspots in your system is session management. The idea of, various informations that you collect about the user as the user logs into your system. And this particularly was one of the case for this one, or the web content management within that. So we decided, I see if the transition will work, because none of my transitions, yes. So we decided that one of the first hotspots that we're going to try out is building a bunch of customer interaction, customer authentication, customer identification, everything that session management was doing as new services sitting in front of the monolith. And similarly, building a new service that was delivering the content. And then get these apps that they were kind of hidden inside this monolith, or pieces of it, out as small, again, micro apps in a way as well. In some cases, the gray shows that we just left the code dormant in there instead of extracting it. And in some cases, if the box kind of disappears, it means that we decided to, in that particular case, extract it. So in some cases, the boxes that we moved, ended up being new services facading the monolith. And finally, in some cases, the services moved into the system of records that they had. And at the end of the day, once we have made either dormant, obsolete, or moved out the functionality, we ended up with lots of small kind of apps, lots of small services supporting those apps. And like any other large organizations, we had system of records, large kind of enterprise systems sitting at the back end that weren't changing as often. This one is hot out of the oven. I've just invented it. It's called Monolith in the Box. So what we found was, when you go through this migration, for a really long time, you're going to be living with monolith and microservices coexisting at the same time. In some cases, both of them are implementing the same function. Some applications routed to one and some applications are routed to the other. And a large waste in your value stream working in that environment is still playing with that monolith. And by playing with that monolith is, your developers building it, running it, setting it up to run in the integration environment. It's just playing around it. It's costly. So what we decided that we're going to build Docker containers that basically encapsulates the monolith and its dependencies, and we will have the latest version of that always available to the developers, so they can spin it up without the overhead of traditional kind of configuration and execution of the monolith. So we call it monolith in a box. We also had this first principle that keep changes to the monolith to minimum, because we knew every time you change code in that monolith, the cost of building and do integration testing, which was the model of testing for that system, was going to be really high. So we'll keep it in a box and keep it at arm's length. And again, because we're going to live in this hybrid world, we have this idealistic kind of principle that at any point in time, if we run out of money in this hybrid world, we should be in a better place. And by better place, it means, towards your business objectives. So if you wanted to go faster, we should be able to go faster if we ended up with half a dozen microservices and a bunch of capabilities is still in the monolith. So recap, techniques for decomposition, or some of the tactics: find the seams, really pay attention to the toxicity of the code. If you want to reuse it, use theory of constraints to find the bottlenecks first, and essentially apply a strangler pattern to build the services around it, and replace the monolith at the end and keep it in a box. And most importantly, when it comes to refactoring, refactor what matters. If you recall the very first exercise at the beginning of this session, we said you will talk to business, you will to know where the product is heading, where the business is heading. So you have an idea where the change happens, where the value is in your system, and really refactor those areas rather than areas that's not probably going to change over time. Service modeling. So you can only imagine at this point the enthusiasm and excitement in the room that we solved our budgeting problem, we got money for refactoring, we have built long-standing teams, and we figured out a way to decompose this monolith. Now we've got to the fun part, designing our shiny new services. But slow down. We really need to think about service modeling. Service modeling is really, really hard. So what I'm going to share with you is, again, some of the patterns and anti-patterns when it comes to service modeling that I've seen. What is the right size? This question that you constantly get asked, is this, how micro is micro? How big should a microservices build? And we've heard over the course of last two talks, a bunch of heuristics as how big it should be. The two pizza team, Amazon's concept. I work in US, pizza's quite large. The two pizzas can feed a lot of people, build large services. 6 people, 6 services, 1 person, 1 service, maybe that's too tiny. Service doing one thing could be your HR function, quite large. James is not in the room, so I can talk about him. James's head size been mentioned, he does have quite a large head. So it's just all these heuristics about how big it should microservices be. And my answer is it depends. It really depends on your organization maturity and infrastructure maturity. How quickly can you build small services and a large number of them? Automation is important. How your teams communicate is important. So there's a lot of complexity that comes with with small services. And to be honest, if I could go back in time and change the course of human history, probably one of the things I would do is change the micro to another name. It causes so much trouble and arguments unnecessarily. We get hung up on the size of the service. So if you're starting, new, and I would say let's go from macro to micro and start with kind of larger services, and really pay attention to the symptoms of having small services. So one of the symptoms that you would see is a really large communication overhead between your teams, because you've divided them to fine grain and to fine grain services. Teams that start alienating, from each other. The big picture is lost. Nobody's knowing what is the big picture. They know about this tiny service they're building, but they've lost the big picture. And then last one is, I see a lot of these kind of simple CRUD services. People who used to do kind of rational, normalized database design and these beautifully designed tables, now exposing those as endpoints over services without any business logic wrapped into those services. So what happens is the business logic and that complexity gets spread out through the system and it's pushed to the consumers. So choose the right size for your organization. Speaking of anti-pattern, this one is another kind of favorite of mine, is this concept of shared utility services. And you're wondering why I've put all these kitchen utensils on this site. So these shared utility or common services remind me of that special drawer that probably every one of us has in their kitchen. So it's that kitchen that you put all the utensils that don't belong in any other in that, and when you try to pull it out, it's usually stuck. It's like that. You put things, concepts that don't belong into a nice bounded context in this one. You end up with generic names like config service, reference data service, utility service. If you got one of those ones, you want to think again. And the problem with these services is that they've got all these unrelated informations or capabilities in them. They couple a lot of different services to themselves. And what happens is if you want to change that, you've removed the ability of independently deploying those services because we've now create this tight coupling. What can we do about it? Well, we can try to keep the reference data as close as possible to the entities that they belong to. So they usually, default values that initialize some domain entities, we'll keep them with those domain entities. And in some cases, we can simply duplicate it. Duplication is not as evil as we thought it is. So, for instance, I've seen country codes being placed on an endpoint on a service. I mean, how often do we change our countries? I'm sure we can manage duplicating country codes in different domain services. And it happens, with the best of our intentions, we divide services along wrong boundaries. The cabbage ends up in the wheat crops. Sorry, I'm just going to grab water. This is one of my favorites. Excuse me. You have to put up with me. One of my favorite, Sampe, he was a New Yorker cartoon. You haven't seen the rest of it. You should go check it out. Farmers are having a lawsuit around the cabbage. But it happens. We might, divide services around wrong boundaries. And often the root cause for that is that we approach design from the wrong angle. So we do domain modeling bottom up. We sit around table or around whiteboard and have these beautiful academic discussions as where should be the boundary of a service. And usually with those ones, we may not get them right because we haven't started from the top-down approach from the consumer's angle. So what I often do is use user journeys, go through the user journeys or consumer use cases, and then decide what services you need to build to satisfy those. A new method that people are using is event storming. So put all the events that happens in your consumer world together and see what services can be producing or consuming those events. And build services that your consumers really need. Look for symptoms of wrong boundaries. Some of those symptoms are confused consumers. So if your consumer of your service doesn't know which services they have to use to implement a feature because they think they've got multiple options available to them, we probably got the boundary wrong. If they're looking for a data field and they feel it's duplicated between two different services, we probably got the wrong boundary. Another test that I use to see whether kind of got the boundary right or not is if you think about one coherent feature that you're building for the consumer, and you think, okay, if I want to build this feature, how many services do I need to touch? If you need to touch more than 3 services, we probably got the boundary wrong because we've removed the ability to be able to release services independently and have that, speed of experimentation and speed of innovation, which is the foundation, kind of principle for this. And if it happens, don't worry. HTS and hyperlinks and Richardson maturity model level 3 can help us. So if you've built with your services with a lot of hyperlinks to different states or different data sets within the service or across another service, that's a very helpful technique to move the services around, to split the services or join them later on. I won't have time to go through details of this, but if you're familiar with REST maturity model, using hyperlinks give yourself a flexibility that to split services without impacting your consumers, because your consumers haven't hard-coded a lot of assumptions about where they can get the next set of data or related states about your service. And the third problem is production automation. So we often jump into, we are so excited about building microservices that we really want to get building and implementing and pushing them to production. So we jump into producing microservices without enough investment into the continuous delivery of that, into automation. So especially at the beginning of the project, when you start a project, you have to make a lot of trade-offs. Am I going to spend my effort implementing the service itself, or am I going to spend the effort building the automation of the infrastructure where the microservice is going to land, automation of the landing zone? Or am I going to spend the time building automated pipelines so I can independently release my services? Shall I implement scaffolding, all those boilerplate code that you have to build around your service to do logging, monitoring, or not? So choose your trade-offs carefully. There has been a fairly healthy track here, continuous delivery, that talks about automation and automation techniques. I won't go through those, but I will try to, share one of my stories with you. About a couple of years ago, we were building a completely greenfield retail, or an application in retail. And we were super excited. There were a bunch of us, and we wanted to put all the microservices goodness into practice. So we started trying everything and go really micro. We made some good trade-offs at the beginning. We had this principle that we will not write a single line of service code until we write a contract test. So we would write a contract test to evaluate, to show how the service behaves, what requests and responses it can get. We build a prototype or mock to demonstrate that, and then we build the service. That was a good decision, but what we failed to do was start with consumer contract tests. What we were validating with contract tests was, as a service provider, how we think the consumers should be using our service. We weren't validating how our consumers are assuming to be using our service. So look into consumer-driven contracts, and that's a good way of kind of testing the services. We did a lot of automation. So we wanted to be able to really push code, to through different environments, run different types of tests, unit tests and contract tests and so on, and be able to deploy automatically. We had many, we had about 60 services over the course of 3 months and 60 plus build pipelines. We had build pipelines that they were testing our build pipelines themselves, so it was all beautifully automated. But the mistake we made was we didn't push to go all the way to production. So we were happily pushing to this integrated or production-like environment, but we didn't take that last mile of going all the way to production because of organizational challenges, the disconnect between people who actually operate the release and production environment. And that really hurt us at the end and slowed us down. So if you're automate the single piece service, the hello world, all the way to production. Don't stop somewhere close there. And we did make trade-offs. We did implement, health endpoints that you could just ping, and either from your load balancer or a user could just ping it and see if the service is up and down. We were exposing health metrics, and we built these templates or scaffolding, or some people call this chassis, which would really help the service builders bootstrap quickly, be able to build the scaffolding around the service and get all that code kind of in the service. But what we failed to do was investing in debuggability. So we didn't build correlation IDs. We didn't have events that would help us to just collect and see what happens in the larger system. So debugging became quite hard. So yeah, choose your trade-offs very carefully early on. And it is a slow to start because there's a whole lot of infrastructure to build to operate microservices. Another thing we did was, we built all these libraries to give us logging, give us authentication of our services, things that were common across services. We built them as one releasable shared library. That was another mistake, and that hurt us going forward because we wanted to upgrade the versions, and we were stuck with one big library instead of independent small libraries, looking after different aspects. So as we spoke, there are many values with microservices, and there are complexities that come with that. So we talked about autonomous teams. You know, teams are made of people. People build silos and walls around themselves. So it's great to have autonomy, but with that comes a communication overhead. We love microservices because they make us go fast, the speed of exploration and innovation. But to be able to go fast, there is a complexity of building automated build pipelines and how to execute microservices. We can scale because now we've broken a large problem domain to smaller subdomains. We give allocated teams to these subdomains to release independently. But building distributed systems that support, resiliency and consistency and all the challenges of distributed system adds complexity. Composability. We love APIs, right? API first. We build services, we build APIs, and it gives our consumers a way of composing services into nice applications and solve weird and wonderful problems. But with that comes the overhead of maintenance, because we have to support backward compatibility now with a large number of consumers of our services. And finally, we talk about tech diversity. Fred talked about how you can use different databases for different services. You choose the right technology for the right service. And now suddenly we've got this explosion of tech stacks that we have to support within the organization. So I suggest that if you're building microservices or heading towards that utopia, get yourselves one of these giant micro sliders and find that right place that give you the net positive value for your organizations where you are, and tune it. And as you become more mature and solve the complexities that we talked about and Fred talked about, then go more micro and find that niche place. I'm going fast, but let's do it. So a lot of the problems that I talked about, are soft problems, are people problems, the communication problems. To be able to, deliver microservices successfully, I leave you with one last word, and that's empathy. We need to, I think, as a developer community, really take a leap in the evolution of our empathy. So if you're building services, think about your consumers first. Build something they need. If you're a consumer of the service, give your test and your assumptions as executable tests to your service providers so they can run it and validate it as part of their service. Build pipeline. If you're a service provider, produce not only service but also mocks to the consumers so they can validate, again, run their services. There are a whole lot of practices that have come up from microservices over the last few years that are based upon really empathetic development. And that's it. Thank you.
We have time for some questions, if you want. The first one, you say no utility services, but how about a log service provided as a software as a service? Think New Relic.
Right. So I guess what I mean by utility services are utility services that tightly couple your services into that. So there are standards, a loose coupling between utility services. So logging as you have a log service that scrapes logs, and it might be reading and aggregating different logs, completely independent of the different services. That's perfectly fine. By utility, I meant common shared services, where a lot of services are pinging and using them with a specific contract. And examples of that are, as I said, reference data or configuration, things that really tightly couple your consumer services. So there are, I guess the different language I would have used for logging are more infrastructure services that exist, like service discovery, log aggregation. They are infrastructure services that we would be using.
Okay. What about composite services? Are they good or bad? Who should own those?
Yeah, good question. Good question. So I think with the kind of advancement of technology, we're moving towards putting composition to the to really towards the front end, towards the edge. So what I've noticed is we used to have this kind of composite or aggregate services. I worked at a bank and they said, you know, we have this page on our application that shows all the different accounts for a consumer when they log into the bank. They can see their loans, their credit cards. So we downstream, they had different services for each of those account types, but they put this aggregate service in the front of it. What they're doing with that is they're penalizing the end user from the performance point of view or even functionality point of view with the slowest moving part of the downstream service. So I think with reactive programming, with event-based, the composition is being moved to the front end as closely as possible because the front end has the most context about the user and they can reactively kind of get events to that rather than having very rigid aggregation services. Having said that, what I've also seen is a style of composition which I mostly call them experience services and not aggregate services. They sit in front of your UI and mostly they provide, you know, data that is kind of closely related to an experience service. But I will see less of those and more kind of push to the front end.
Okay. The responsibility for consumer contract testing, does that lie with the service implementers? Is the question, or where is the responsibility?
Sure. So the idea behind consumer-driven contract is that you know, the responsibility of producing the contract, obviously, it's with the service provider. At the end of the day, it's the service provider who's writing the service, so they know what contracts they can satisfy. However, the implementation of that contract test, how am I using as a consumer the service, lies within the consumer. So consumer produces the test and executes the test, obviously, as part of their own to produce the contracts. The service provider consumes the test to run their services. So the creation of it lies within the consumer. The execution of it lies within the service provider. We had this kind of, again, in that project that a bunch of idealistic people were building lots of services too quickly. We had this idea of self-healing pipelines. So we started using consumer contract tests and we said, what if we reverse this responsibility? What if the consumer could tell us what they want differently from a service by breaking the contract? They add a field. What happens next is the build pipeline of the service provider breaks, and the service providers can quickly react to healing that pipeline by implementing the service. So it's a way of kind of self-healing, and I hope maybe one day we can reach there. We never managed. So I guess the responsibility of the contract stayed with the service.
Any other questions in the audience? No?
Thank
you very much, Zhamak.
Thank you.